more we have discussed yesterday forecasting, and we have seen some inventory models also, right? So next our concept is that job scheduling. Okay. Job scheduling. Right. So actually, what is job scheduling means? Suppose always I told you yesterday itself. So whenever you discuss about time and over, you always imagine that you are maintaining one company, so that you will be able to understand very well, right? Now you have one small scale industry. In that, some lathe, some drilling machines, one shaper are there. Now you have a jobs to perform the operations and produce the component. So whenever your jobs or raw material enter into the workstations, you need to allot in a proper way. No machine should be ideal. Okay. Suppose based on the workpiece, suppose we have discussed nut and bolt. How many operations required for nut and bolt? So for producing the nut, you require lathe. After that, threading, and then so next bolt. First is turning, and then make it into hexagonal shape, and then drilling. 5 operations are there. These 5 operations we have to in such a way that no component is waiting and no machine should be ideal. Then only you will get maximize the production rate, isn't it? So for that, how we need to sequencing the jobs. So how to maximize the efficiency of the machines as well as the utilization of the machine and efficiency of the that particular components. So that is come under job scheduling. Okay, properly allocation of the resources in order to get the maximum efficiency. Whenever you are getting the maximum efficiency, obviously you will get maximum production, more profits. Okay, right. So all these techniques like break-even analysis, inventory control, forecasting, all these things to maximize our efficiency of the industry. These are the tools which we apply. Okay, for various industries, various tools will be utilized. Okay, so we cannot say that one particular business or one particular organization will be involved in only these tools. Okay, it depends upon our requirement. Now let us go for see that. Now have a look on this job scheduling sequence concerned with determining the best sequence in which set of a given jobs may be performed, where scheduling is deals with the allocation of limited resources over the time. Okay, is it visible? Yeah, right. Now, right. Next, see that allocation of it deals with the allocation of the limited resources over the time. So within the available resources, limited resources, how to maximize the production. Next, the sequencing models are deal with the situations where n jobs are to be processed on n missions. We don't know that how many jobs are there and how many missions. So based on the n job, n missions, we need to allocate. No mission should be ideal. No object should be waiting for the getting the operation like that, right? The optimal sequence which can optimize overall completion of the time of all the jobs in all missions. Okay, right. Now let's here what kind of activities we have. Right. Here only I'll highlight. Is it okay, or we'll go for the next? What conditions we have? Right. Now here you take this kind of things. Right. Now classification of sequencing modeling problems. Okay. If n jobs are there, one mission only. If n jobs, 2 missions are there. N jobs, 3 missions. Most of the times the question is coming from n job 1 mission, mostly n job 2 missions. Okay. And however, we'll get the question from n job m mission means we don't know that number. Jobs are 10, missions maybe 15. Like 2 jobs, 1 mission. Okay. Now here, if you understand that n jobs 2 missions, so that we can extend our solution for N jobs for 3 missions. Okay, all are in similar category. Next, sometimes there is a possibility that 2 jobs and M mission, right? So actually, the topic what you are going to study for GATE or any competitive examination, so you just prefer that last at least 7 to 10 years papers and get job and sequencing questions. How they are asking. Based on that, your preparation has to be. If you find out that most probably you will find the questions in 2 or any 3, that's it. Then you find out one scenario. Last year, which topic came? And before last year, which topic came? Either it is a N job 1 mission, either it is a N job 2 mission, like the 2 prediction. This year, maybe, suppose last 2 years they cover these 3. And this time, maybe next one. So like that, you have to predict. That is a smart work. Okay. So like that, here also we need to go to study that what kind of questions are going to be coming from N job 1 mission, N job 2 missions, N job 3 missions, and whatever the possibility situations are there, that we are going to discuss. All right, clear everybody? Right. Now take this 3. Classification of sequencing models or sequencing problems. Right. So you take this 5, then terminology we will look into that. Terminology. Here is okay. Terminology. By the time all comes, then we will cover some terminology theoretical part, so that we will go for the problems. Right. Right. Now here, for solving these kind of classification sequencing modeling, what terminology we use? So basically, terminology means what terms are continuously we are using in solving the problems. Now, first, processing time, and then due date. What is a processing time? Processing time is nothing but whenever the job is come into the workshop or machine shop, how much time it is spending on the machine to get the completion of the operation. So machining time, we can say that it is a processing time. How much time it is processed for one mission, next one more mission, or in order to, once the raw material enter into the workstation, and how much of time it is spending in order to complete, in order to get it a complete shape or complete product, that is come under processing time. Next, due date. How can we define due date? Due date is a fellow, suppose our our vendor or else our customer, he may ask that too, sir, I require this much 200 components in next upcoming 2 days, or else in particular day they will ask you to produce. So that is come under due date, right? Now take that processing time. It represents the processing time of the job on J machine. Okay, it is a represents the processing time of a job J. Job is J, guys. Job J on mission I. On mission I. The substitution is, that is not required. Just up to here only. J only to be the proceed to on mission. Next, due date. Due date data DJ. It's better to write. Now J we consider it as a job. Now I we consider it as a machine. Right. Where due date is DJ. All right. So for job J, all right, represents the committed shipping or completion of the date. Okay. So when you are committed to shipment or completion of the date, that we call it as a due date. And the completion of the job after its due date is allowed, but a penalty is induced when the due date must be met. It is referred as a deadline. Okay, so take this also. The completion of the job after due date is allowed, but the penalty incurred when the due date must be met, it is referred as a deadline. Okay, suppose we committed to deliver the components on some particular day. Before that, you can finish. But if you are not able to finish within the due date, then you need to pay penalty. Okay, that means if you take extra time, but early finish is okay, right? That we will solving the problems. You will come to know that what is the due date. If it is actually what is the average lateness, so flow time, all these things we need to calculate. That we will see, right? Next is ready time, the time at which a job J is available for processing. That is called, ready time. Ready time means the job is ready to proceed machining. Next, completion time. Completion time. The span between beginning of the work at which time is referred as a t equal to 0 and the time at which task is finished. That is called completion time. The time between starting and completion. Of course, small terminology only, but if you understand these kind of small things, then it is very easy to solve the questions. Okay. Right. Next is make span. Make span. Make span defined as a maximum C1, C2, and it is equivalent to the completion of the time of the last job to leave the system. What do you mean? What is a make span? No idea? See, so 10 jobs are coming into the system. What is the time lost job leave the system? So lost job will get obviously last only operation. So first come first serve. First job will get finished, second job will finish, and third job will finish, and fourth job will finish. But what is the last job to leave the system? That is come under make span. Okay, the make span defined as a maximum and it is equivalent to the completion time of the last job to leave the system. Okay, that is called make span. So sometimes they ask you to calculate and is equivalent to the completion time of the last job leave the system. All right, so these are all the terminology. These are only we are going to what to say calculate from the job sequence. Like next, flow time. Flow time, the time span between the point at which the task is available for processing and the processing time plus the waiting time, called flow time. Okay, the time span between the point of which a task is available for processing and the processing time plus waiting time is called, what is that? Flow time. That means, see, one job is engaged in the machine and it takes the processing time 3 minutes, right? And another job is finish the operation from the next mission before mission, and it is finished and get ready. Suppose say that it takes 5 minutes time to finish, but 4th minute only next job came. Though this job is waiting, then this job is get finished after 5 minutes only, right? Then 1 minute is a waiting time. So that waiting time plus processing time is come under flow time. Hope you understand, right? So many missions are there that will you will come to know while solving the problem, but you try to understand one thing. Whenever the flowing is happening, so any job is waiting at a machine for getting the processing. At that time, the same machine will be in the engage. The processing time plus waiting time come under flow time. Right. Processing and the processing time plus waiting time. Next, lateness. Next is lateness. The deviation between the task completion time and its due date. The deviation between task completion time and its due date. Hi, take that. Then, so targeted date is 10th, but fortunately you finish your job by 7th only. Your lateness minus. That means early it is completed. Okay, so before the due date it is completed, negative lateness. That means early happened, early occurrence. So before the, after the due date it is completed, then it is considered lateness. That's it. Okay, right. Now here deviation between the task completion time and its due date. That's it. So you just write whatever I am highlighting, that points only you note it down so that you can easily understand. And it is a deviation between task completion time and its due date. Okay, a task will have positive lateness if it is completed after the due date, and negative lateness is before its due date. That's what I told you. Before due date it is finished, negative lateness. That means early finish. After the due date finish, it is come under lateness. Lateness is comes into picture whenever you are not finish your job targeted date or due date. Clear? Hope you understand. Right. Next is readiness. It is very important. Readiness. Here it is a completion time, maximum completion time. Next, FG is a flow time. Sometimes they will ask that flow time, indirect question, that I'll tell you. Next is, this terminology. What is lateness? LJ. Lateness means job processing time minus delay time or waiting time. Next, readiness. Readiness can be defined as it is the measure of positive lateness. If task early, it has a negative lateness but zero readiness. If task has a positive lateness, it has equal positive readiness where TJ is a minimum. What do you mean by readiness? If we consider positive lateness, that is come under readiness. So modulus of lateness called readiness. If suppose lateness is minus, then readiness is 0. Okay, so there will be a no negative readiness. Are you getting my point? Whenever readiness comes into the picture, whenever you want to calculate the readiness, you need to calculate lateness and then take modulus of lateness. That is come under readiness. All right? Yeah. Positive lateness. Simple. It's a measure of positive lateness. If the task is early, it has a negative lateness. So at that time you have to consider 0. If task is finished early, then negative lateness will come. That time your readiness is 0. Right. Next, if the task is positive lateness, it has a equal positive readiness. Okay. Right. Next, maximum lateness. The maximum lateness Lmax is defined as L1, L2, L3, and so on. Hope you understand, guys, this terminology. So very, very important, all this. So ready time, completion time, make span, flow time, lateness, readiness. Okay. So these are very important guys. Right. What we need to calculate in make span in job and sequence. Right. Flow time, that means sometimes they will ask you average flow time. Average flow time. That means we can call it as F bar. Okay. So why we call it as average means sometimes in jobs one mission, more number of job one mission only. Then how many missions, how many jobs you finish? That is come under flow time. Average of all this. Right. Next is sometimes average readiness. Right. Next, lateness. Minimum make span. Minimum make span. All right. So these are the basic things. Completion time, that is completion time. You can say processing time also. Hope you understand, guys. Right. Can I go for next? Right. Now let us move for notations. You take this very must and should. What are the notations we used in the calculating problems? N equal to n number of jobs. M equal to number of machines. Ti is a processing time, jth job on ith mission. Okay, Tij it is. We say it is a Tij. That means on the J job performed on the 8th mission processing time. Next, ready time Rj, and flow time for a job. Completion time for the job only J, and due date, lateness, readiness, number of ready jobs. Imax, maximum lateness. Cmax, maximum make span. So make sure that all okay. Then we will move for right? What assumptions we need to make sure that, you know, all jobs are ready to process assumptions for job sequencing and scheduling. Definitely one question here, 2 marks. Very simple. So they'll ask you that some direct questions only. So that I let you know from my note. Right. All jobs ready to processing. All processing times are deterministic in nature. Machine is flexible and can be processed jobs without any breakdowns. Okay. Before you are scheduling, you need to make sure all these assumptions, or else make sure whenever the industry having these kind of facilities and workflow is making flowing in this manner, then only it is possible to do that job scheduling. All right, next, no permission, no pre-emission, that is the jobs cannot be unloaded without having completion on a mission. Okay, right. Next is traveling time and setup time of jobs are negligible. So setting time and traveling job from one mission to one mission, that time we're neglecting while calculating the sequencing. All right, next. Now here one job and mission. This I don't think this required. Anyway, I'll copy for you guys. You must study now. In jobs one mission, how to solve. So in that we have a shortest processing time model. This is we use shortest processing time, SPT. Next, early due date, EDD model, right? So first come first serve and last come first serve and least slack value and longest processing LPT. Longest processing LPT. These are the steps or methods which we use for solving the problem in n jobs, one mission. Okay. SPT rule, EDD rule, first come first serve and last come first serve and least slack value, and then longest processing time, LPT. These are the techniques which we use for solving the job sequencing models. Right. So only highlights you heading. Right. Least slack value, if you want, you can take this definition. Slack value is defined as the difference between the due date and its processing time. Difference between the due date and its processing time. Priority given to the jobs which is having minimum slack time, its processing time and its due date. So you take the slack value. This is very important. These two lines. Slack is defined as the difference between the due date and processing time. Slack is equal to difference between, that is processing time minus due date minus processing time. Due date minus processing time. All right, guys. Due date minus processing time. And so minimum slack value we will consider. Critical ratio. Now another method for solving this. It's not required critical ratio. Right. Next, critical ratio. Dates required minus today's date divided by days needed to complete the job is come under critical ratio. But I don't think in critical ratio we'll get the question. All right. critical ratio is less than 1, always the job is behind the schedule. The job is behind the schedule. Critical ratio is equal to 1, the job is on schedule. Okay, right. If critical ratio is greater than, ahead of the schedule. So as if critical ratio is more than 1 means it is early completion, and CR is less than 1 means we schedule for some time but it is not able to meet the our scheduling. It is on time. As per the rule, jobs are loaded in the increasing order of the critical value ratio. Finished off? Right. Very good. Next is, can I keep it for some time? Can I go for next? Now, if it is end job, 2 missions. If end job, 2 missions. Here, this fellow plays a very, 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 very major role. Jansen's algorithm. Jansen's algorithm will comes into the picture whenever you have end job 2 missions. We'll use Johnson's algorithm for finding the job scheduling. Okay, right. Now note that Johnson's algorithm can present optimal job sequence which can be minimized make span in case of end job 2 missions. Very important. Sometimes you may get theory questions where particularly Johnson's algorithm is used. Whenever end jobs 2 missions are there, in that case it will give optimal sequence and also make span is minimum. What is a make span? Just now we have discussed. Last job it is going to leave from the organization or from the workshop. Okay. Now that is the maximum time that is spent in that. That we call it as a minimum time. That will be minimized. If that minimized means production rate is increases. Okay. Right. Now, now Johnson's algorithm can represent the optimal job sequence which can minimize the make span in case of in case of end job 2 missions problem. All right. Next is end jobs 3 missions. This is also fine, but you don't get question from here. But however, you try to read it. What if you able to solve the end job 2 missions? The same we can extend to the end job 3 missions. All right. It's a procedure you can study because we are saving this file. Now we can study. But here SPT rule, EDT, slack time, tardiness, average flow time, Johnson's algorithm, very important. From there only we'll get the question, right? End job, end missions. So it will be useful for your future. Just have a look on this. Two jobs, M missions. Missions are more, jobs only 2. More number of missions, jobs only 2. Okay, this is another one. That's all about this. Okay. Now let me engage with my note so that you will be able to understand little good things. In a crispy way, I made it. Where is my book? 1 minute, please. I have not copied it. What happened? Huh? Nobody's coming. Huh? Why? You don't like I am on what? Huh? Right. Now here I made it my note little crispy. I hope this will be helpful for you guys. Right. Now, sequencing and job scheduling. In that, I just explained, then we will go for the problems. Okay. So, whatever the theory or what I have covered, it is for syllabus. Right. But the question where is it is coming from? So, from there, you need to study. This crispy manner will be helpful for you right now. So, most of the possibility, first possibility of the question will come from chapter N Jobs, One Mission. Okay, first case only. In job, one mission. Next, here we'll have two options. One is SPT rule and EDD rule. I told you right. SPT rule shortest processing time. EDD rule means earliest due date. Okay, right. Now here 99% chance we'll get question from these two rules. Okay, right. Next is 1% chance in getting critical ratio, least stack, first come first serve, last come first serve. Okay, so this is I made based on our previous year's question paper. Okay, right now in that what are the possibilities? So possibility that to get the question, find average flow time to SPT rule. Sometimes find out that average tardiness, T bar. F bar means flow time, T bar means tardiness, right? So this is from SPT rule. This average flow time also use SPT rule. Next, find out F bar using the average flow time EDD rule also sometimes. Next, find out tardiness using EDD rule, right? So T bar, F bar can be calculated by SPT rule. F bar and T bar can be calculated also EDD rule, right? Now, if rule is mentioned in the problem, then no issue. We can solve the problem anywhere. If rule is not given, we have to find what it is. Either it is a SPT or EDD or Johnson's algorithm. Are you getting my point? This is a shortcut way to approach gate question. So that means, see, you studied all that N jobs one mission, N job two missions, N job three missions, N jobs M mission, but you fail to identify which one is suit for your question. Question is coming from where? That is quite important. That is why this kind of shortcuts, right? SPT rule can be used for T bar, F bar. EDD rule also can be used for F bar, T bar. If rule is mentioned, that's not any problem. If rule is not mentioned, then they will ask the question in an indirect way. Okay, so now let us see that. What is that indirect way? Right. Now see here the indirect question coming like this. What is the minimum average flow time, they will ask. What is the minimum average steadiness, and then what is the minimum total inventory cost or carrying cost, In this case, we have to choose a rule. Whether it is suits for shortest processing time, F bar, average flow rate. If it is average flow rate means F bar. EDD, it is given readiness, right? Next, minimum total inventory carrying cost equal to for F job into holding cost. That we will see in the problem. Okay, so processing time into a cost of that we will get, then inventory carrying cost, we can do that. Hope you understand, right? I just simplified how to utilize that. Okay, right. Next is, now see here, next possibility of the question, end job 2 missions. Next possibility of the question, end job 2 missions. All right, right. Now here what happened na? Similar, all we need to end jobs means more number of jobs, all are similar only, same amount of the jobs. Either say, just now I say that all jobs are cylindrical jobs only, like nut and bolt combination, right? Next, first operation, second operation, 2 missions are there na? First operation, second operation. Next, generally preferred for batch production. Whenever you want to produce the components in a bulk, single object, large in number, that time we prefer this kind of technique. Okay, right. Johnson's algorithm used for solving the problem. Okay, so Johnson's algorithm gives optimum job sequence. 8 jobs or 10 jobs, then sequence is asked. Sometimes, see, n jobs I said. What is mean and either it is a 2, 3, 4, 5, 6. If they gave that 8 or 10 jobs, they will ask only sequence, right? If the jobs are 5, 6 are there, they ask you to collapse time. That means either flow time, tardiness, lateness. These kind of things will ask whenever jobs are only 5 to 6. Whenever jobs are more, that time only they will ask sequence. Hope you understand. Make span and that times will be asked. Okay, next is. For finding the elapsed time, job sequence is required. Apart from this, n job 3 missions, n job m missions, 2 jobs m missions, but you can't get the question from this because it is a very lengthy problems. So GATE will not ask this kind of lengthy questions. That is why you focus on n jobs 1 mission and n jobs 2 missions. If you are able to solve that n job 2 missions, then you can able to solve your, if you know n jobs 2 missions problem, so that you can extend your answer n jobs 3 missions also. If you understand n jobs 2 missions, it is possible to understand n job 3 missions as well. Clear? Hope you understand, right? Next is now, okay, now we'll go for the problems. It's like really okay. Next is right. Is it okay? Right. A set of 5 jobs is to be processed on a single mission. What is it? N jobs, 1 mission immediately. Single mission. The processing time in days and due days are given in the table. Processing time is given. Age of processing time 5 days. Its due date is 8 days. Next, job time is 8 processing days, 11 days due date. C time this much, right? The shortest possible average readiness, right? Take the table for solving the problem. Finished up? Now, average readiness. What we need to take? Average readiness means EDD rule. Based on the EDD rule, we need to solve the question. Right. Now, let me explain you what is EDD rule. Early due date rule. Right. Now, here I will take a job. So processing time PC I'll take, and oh god, it will take another table. No problem. So we'll make the table later stage. Now let us move for see that. See, based on the early due date, you need to first find out the sequence. Okay, first step is that to find the sequence. So have you engaged anywhere this question? You done? Huh? You know this? Huh? Production engineering. This is there now. You know. You have no idea. Oh my god. Right. So based on the early due date, you need to find the sequence. Right. Which one is the shortest earliest day? Shortest earlier day? A. So first job is earliest rule means select least earlier due date. Okay. So due date you select least one first step. Right. Now here, how can I write my sequence? Right. First one is A, and second list is B, and third list is E. Next, fourth list is D, and fifth list is C. This is your job sequence. So whichever having the least due date, that will finish first. A, B, B, E, C, D. Okay. Now next you just take that table. Okay. Now whatever the job sequence, job and its processing time, right? Due date, and here readiness. So for that readiness, what we require? We require flow time. Oh. 1 minute. Based on your requirement, you are supposed to do that. Okay. Right. Now, flow time. Next, processing time. After that, lateness and readiness. And due date, lateness, and readiness. Right. Now, what is the job sequence, guys? A, B, E, D, C. A, B, E, D, C. So now here my A, B, A, B. What is the sequence? E, D, and C. All right, guys. Right. Now let's see that processing time of this. What is the processing time of processing time? 5, 8, and then 11, 6. Processing. Huh? 6. Are you sure? Then it is A, B, E, D, C. Then it is 5. How would be 5, 8, 3, 9, 6, right? Right. Now let us see that. Right. Now processing time is 5, A is 5, and B is 8. Okay. We have EDD rule. Huh? Okay, I'm thinking about this. Okay, fine, no problem. Now your processing time 5, 8, 6, and D is 9, and it is 3. Please come. All right, guys. Done. Right. Now here flow time. Flow time. Actually, you take the processing time this side, or you already drawn a. Okay, leave it now. So cumulative of processing times is come under flow time. Very simple. Now it is a 0 plus 5 equal to 5. So next 5 plus 8 is equal to 13. Next 13 plus 6, 19. Right. 19 plus 9, 28. So oh, right. Now here 19 plus 9, 28. 28 plus 3, 31. Right. This is what flow time. Next due date. Due date you select according to your job sequence. You applied EDD rule, na? Then your job sequence got changed. So which one is the minimum due date? That is come first. That is why. What is the A due date? A due date is 8. Next B due date 11. Right. Next C due date EE 18. Right. Next D due date 19, and it is a 21. Right. Yes, guys. Now here, what is lateness? What is lateness? I gave you the formula, right? Processing time minus due date. Right. Now lateness is equal to processing time minus due date. Processing time minus due date. Minus due date. All right. Now here, what is the processing time? Not processing time, flow time, guys. Check it once. It's a flow time. Flow time minus due date. Right. Now here it is gonna be a 5 minus 8 is equal to minus 3. Next 13 minus 11 is equal to 2. Next 19 minus 18 is equal to 1. So next 28 minus 19. How much it is? 9. Right. Now here 31 minus 21. Then it is going to be a 10. Right. What is readiness? Modulus of lateness. Right. Now here modulus of lateness. That means positive lateness. Right. But here we have a negative. What we should do? 0 we have to consider. That I told you. 0, 2, 1, 9, 10. So what they ask you to calculate? Average tardiness. Right. So average tardiness is equal to average tardiness is equal to T bar. That is going to be how much? Sigma all. Right. Now 0 plus 2 plus 1 plus 9 plus 10. How much? And how many number of jobs? 5. Isn't it, guys? Cumulative of all these, and then 5 number of jobs, 5. Then it is equal to, I guess it is 9, 10, 22 by 5. So what is your average steadiness? T bar? T bar is equal to, it is 4.4 is your average steadiness. Like that you are supposed to solve the, what is that? EDD rule. Right. Now here, what's your answer? 4.4 days. Hope you understand. Do you believe that it is a 2 marks gate question? So yes, simple and easy like that. Okay. Now let us move forward. We'll solve one more question. told you some convol, no? Right. Now, you saw this SPT rule. Try to solve. Right. Now, have solved? How much? You got it? Very good, very good. Right. Now here SPT rule you are supposed to use. SPT rule, shortest processing time is the first, and then next shortest processing time the next. Okay. Right. First you need to find the job sequence. Job sequence is equal to, so shortest processing time. So which is the shortest processing time among all these, which is shortest processing time? SPT rule. Shortest processing time rule. From there, then your job sequence is first shortest processing time, first job, and then next third job, and then next fifth job, and then next 5, 6, and sixth job. Then 9 is second job. That's it, and then fourth job. So here, how many jobs here? 6 jobs, 1 mission. SPT rule, average flow time we need to find. For that average flow time, F4 will be the average flow time. Isn't it, guys? Right. Now you need to find that average. So we design with this rule. You need to follow this sequence. Again, you form the table. Right. Now here. Right. Yeah, why is shouting like? Job, and next is processing time. Next is flow time. That's it. Only flow time they ask you now. Right? Job sequence. Which job sequence you are supposed to follow? And whichever you have made, newly by considering the SPT rule. Okay. Now 1, 3, 5, 6, 2, 4. 1, 3, 5, 6, 2, 4. One, 3, 5, 6, 2, 4. Right? This is what the job sequence you are supposed to follow. Clear, everybody? First step is that finding the job sequence based on your processing time. That means based on the SPT rule, you need to find the job sequence. Alright, next. Next. Right. Now, what is the processing time? Please let me know. I can go back here. Processing time of first job. For next. Third job. This fifth job. 6. 6 job. 8. Next. Second job. 9. And this will be 10, I guess. Right. Next, flow time means I said that it is a cumulative of processing time. Right? Better you write sites, step by step. The piece, whenever you going to prepare and it looks new, why flow time comes. Right? That is why first 0 plus 4 is equal to 4. Next 4 plus 5, 9. 9 plus 6, 15. Next 15 plus 8, 23. 23 plus 9, 32. 32 plus 10, 42. Right? Now here average flow time. The average flow time is, average flow time F bar is equal to average flow time F bar is equal to. Alright. Now here add all flow times, that is 4 plus 9 plus 15 plus 23 plus 32 plus 42 is divided by how many number of jobs? 1, 2, 3, 4, 5, 6, 6. Then you are going to get definitely this answer. This is how you need to apply SPT. Alright. Let me know how much. Huh? 20.83. Yes. Now your answer will be yes. So believe that it is a 2 marks gate question. Sound. Now let us go for. Can we solve another question? Right. What happened? Right. We'll solve one more question. Right. This time. We solve this. This can easily. Right. So I don't think it will take much time for you. What up? Where? Now tell me. So 4 jobs have to be sequenced on a single facility with the objective of maximizing the lateness, minimizing the maximum lateness. The due date and processing times of the jobs as follow. Then last job should leave the takes place. Which one? How come? Q. Which job leaves the workstation last? I told you in the beginning itself. Here we need to decide either it is a SPT rule or EDD rule. It is a SPT rule or EDD rule. You have to decide. How can you decide? I told you, average flow time means SPT rule. Lateness, tardiness will come EDD rule, early due date. Right? Now here it is come under early due date, guys. Right? This fellow is your rule. So that is what in the beginning of the chapter itself I told you that. What is that? So whenever you engage with the problem, you need to decide based on the data. You need to decide, and based on the question asking, you need to decide which rule it is going to be settled down. Then only it is possible to find out the things. All right. Now here, earliest due date, that is based on the EDD rule. Whichever the earliest due date is R. So job sequence is R. Next is P, and then next is Q, and then next is S. So last job leave the system is S. So whichever having the lowest earliest due, that is lowest due date, that one is the first. Then next list, and then next list, and then next list. So you have to sequence, have to follow like that. Okay. Hope you understand. Clear? Right. Can we go for another question? Good. Next is another question. After solving the EDD SPT, and you will get a confidence that will go for Jansen's algorithm. All right. Right. Now try to solve this common data question. 4 jobs are processing in a right processing time and due date is given. When the jobs are processed according to the SPT, the mean flow time, average tardiness, and number of trading jobs respectively. Similarly, if the jobs are processed EDD rule, then what is the mean flow time, what is the average tardiness, number of trading jobs respectively. It is a lengthy problem, so try to solve it. Here we have to go with the what is that SPT rule as well as the EDD rule for the same job. Okay, so try to finish it quick. Can I do directly? SPT rule. Will you solve? I'll give 2 to 3 minutes time. You try to solve. Tell me. You need to form a table. It's not like simple. Which one? Okay. How come? What's your mean flow time? Okay. Average tardiness. No, 3 are there. You need to find. See, guys, for this rule, SPT rule, F bar, T bar, and number of trading jobs as well. Similarly, in the EDD rule, they said here it is a SPT rule. Here it is a EDD rule. Now here, mean flow time, average tardiness, again number of trading jobs. 3 you need to find. Okay. So you try from your side. I'll also do that. What happened? Huh? A is answer. So let me know your average flow rate, flow time, average readiness, number of trading jobs, 2. Trading jobs means positive lateness. Whichever having the positive lateness, that is a trading jobs. Alright. Now let me solve from my side. Right. So first SPT rule. According to the first case, first problem, SPT rule. Shortest posting time rule. Find the job scheduling. Job scheduling you find based on the SPT rule. Yes, guys. Right. Now here, based on the SPT rule, what is that? Shortest processing time is third job. So third job. So next shortest processing time, first job. Next shortest, second job. Third shortest, fourth job. Right. Now after that, just form a table. Right. Form a table, job and processing time. Right. Next, flow time. Next, lateness minus tardiness. Sorry. This is what you need to calculate. Right. This is what you need to calculate. Right. Now here, job sequence and your processing time, flow time, lateness and tardiness. This is what you need to do. Alright guys. From here, what you have to do. So now your job is 3, 1, 2, 4. So what is the processing time for 3? 3 processing time 2, 4, 7, 8. Right? SPT rule means you have to consider shortest processing time. SPT rule means processing time. EDD rule means due date you need to consider. Right? Now, flow time, cumulative of this fellow. So that is 0 plus 2 is equal to 2, 2 plus 4 is equal to 6, 6 plus 7 is equal to 13, and 13 plus 8 is 21. Right? Next, lateness. What is, oh, we forgot the due date, na? We need to maintain one more thing, due date required. So one more column you made, due date is needed. So due date is okay. Here I need to erase all. I just take a small column here. Can I write due date here? Right. Due date is equal to, for first job or third job due date 19. Next, 6. First one is 6. Next, second one is the due date is 9, and fourth one is 17. This is 9 and this is 17. All right, guys. Right. Now here, what is the lateness? Lateness is equal to flow time minus due date, isn't it? Flow time minus due date. Right. Flow time is equal to, it is 2 minus 19. So that minus 17. Press next. 6 minus 6 is equal to 0. Next, 13 minus 9. It is going to be a 4. Next, 21 minus 17 is equal to 4. All right. Now, what I said that flow time minus, you write a formula if you want. Flow time minus due date, lateness means. Flow time is what? First job flow time 2, second job flow time 6, third job flow time 13, fourth job flow time 21. Clear? Right. Now let us find the tardiness. Tardiness means, so here if you want, flow time minus due date. Flow time minus due date. Now 2 minus, please come. 2 minus 19, 6 minus 6, like that. Here, modulus of lateness. That means modulus of lateness. That is positive lateness you have to consider. But here, whenever lateness is negative, then tardiness you take 0. Negative means 0. Now 0 and 4 and 4. This is your tardiness. Clear, everybody, guys? Right. Now let us find that average flow time. F bar. Here only I'll solve. F bar is equal to flow times of all jobs. 2 plus 6 plus 13 plus 21 divided by how many jobs? 4 jobs, right? 34, 40, 42. 42 by 4. Then it is going to be a 10.5. Next, average readiness. T bar is equal to 0 plus 0 plus 4 plus 4 divided by 4 jobs. So that it is going to be a 2. Right? Trade jobs means the trade jobs which are having the positive value of trade, that we call tradiness jobs. So your jobs of tradiness are 2 jobs. So your answer is A is your answer. Alright. Similarly, consider EDD rule and solve. EDD rule and solve. Now we have solved first question. Then go for, have you taken this? Getting bored? D answer. Great. Well done. Now I need to know the values. Mean flow rate, mean flow time. Don't see. Look at your book and tell me your answer. Average steadiness 1.5. Number of steady jobs 3 will come. Very good. Now I just make sure that others also join. Next we'll go for Johnson's equation. Finished now? Okay, right. Next is don't take it as light because of they are easy, but see, practice also needed, right? Now next, uh, here second one we will solve. So next problem I'm expecting from your side, guys. Right. Now here second question, then EDD rule. EDD rule, right? Now from the EDD rule, shortest earliest EDD rule, earliest due date. EDD means earliest due date. Which one is earliest? First job only, na? First job only due days is only 6 days, right? So first job, next list is second job, next list is fourth job, and then third job. Is it okay, everybody? Lowest due date to the maximum due date. Finished now? You done? Well done. Right. Now here again take this one, right? Table, that is a job sequence. Next, processing time. Right. Next, flow time. Next is due date, right? Not processing time, not required here, I guess. Okay, leave it. Next is due date, lateness, and then tardiness. Next is tardiness. Now you form a table. All right. Right. Now here job 1, 2, 4, 3. Right. Processing times. Sorry, processing times is one job 4, second job 7, and fourth job is 8, and this fellow is 2. But here you need to find early due dates. So early due date is equal to first job 6, second job 9, fourth job 17, and its fellow 19. Now flow time is cumulative of this. 0 plus 4 is equal to 4, 4 plus 7 is equal to 11, 11 plus 8 equal to 19. 19 plus 2 equal to 21. Done everybody? You solved? Okay, very good. You, all of you solved. Oh my god, you are so speed today. Right. Next is flow time minus due date. That is equal to 4 minus 6 is equal to minus 2. 11 minus 9 is equal to 2. Next, 19 minus 17 is equal to 2. And then 21 minus 19 is equal to 2 again. Right. Now here, modulus of lateness. Lateness means flow time minus due date. Flow time minus due date. All right, guys. Now tardiness, positive lateness, modulus of this one, right? It is 0 and 2, 2 and 2. So tardy jobs are 3 jobs are the tardy jobs, right? Next, similarly here, what they ask you to calculate? They ask you to calculate mean flow time, average tardiness, and number of tardy jobs. Number of tardy jobs are 3. So positive value of tardiness. Next, F bar, you find that F bar. F bar flow time is equal to, what is the flow time? 4 plus 11 plus 19 plus 21 divided by 4. Let me know this, how much? It is going to be a 13.75, right? 13.75. Next, average tardiness. So it is 0 plus 2 plus 2 plus 2 by 4. It is going to be a 6 by 4. So that you are going to get it is a 1.5. What do you say, guys? Average tardiness means then add all the tardiness values and divide it by number of jobs, so that you are going to get. Now flow time is also like that. Number of tardy jobs means 1, 2, 3. So rest of the things are 0. I hope everybody clear and understood, right? Can we go for next question? Right. Next is excuse me. Yeah, you solve this quick. I don't think it will take maximum 1 minute. Ah, who's called me? Don't talk. Which rule it is? Very good. Excellent. What's your name? Huh? Okay. This is your answer. All of you got that? EDD rule. Do that. Don't take light. Huh? Jobs are simple. That is why you are neglecting. Then you lose. Practice also required. Na? Here only you will practice. In home, I don't think you will study. At the time of exam only you will study. Yes? C is the answer. Both are C only, na? Right. So here, two negatives will come. Two zeros. That means. All right, can we go for next? Finish, everybody? You understand? You got the question? No. Okay, I'll give question and come to you. Okay, right. Right. Now find this. Is it sufficient? Visible? We have covered a lot. Yeah, slack value equal to due date minus processing time. Do that. Right? It's again 2 marks gate question. Yeah. You understand previous question? Which one? This one. 3 previous question. Show me that. Not this. You understand this? Oh yeah, this problem. What they ask you to calculate? EDD rule. EDD rule means earliest due date. Whichever is the shortest one, that job sequence you have to make. This is the first sequence. E. Next list 5. Next list B. C, D. This is a job sequence. And then form the E, A, B, C, D. And then processing times and due date. So flow time. Flow time means see processing time how much? E 1. A 3. Next B 4. C D. Flow time. Flow time means here cumulative of this 1, 4, 8, 10, 16. Due date for E. You need to follow this sequence 2, 5, 6, 9. Right. Lateness. Flow time minus due date. Then tardiness. Modulus of that. Okay. If it is a negative coming lateness, take it as 0. That's it. Very good. Very good. Huh? Yeah. So if they ask that, what they ask that mean flow time. Flow time. Sum of all these. How many jobs are there? 5. Sum of all this divided by 5. If they ask tardiness, sum of all tardiness by 5. Then average lateness, sum of all lateness by 5. Okay? Hope you understand. Right. What is least lag? Least lag equal to due date minus processing time. Due date minus processing time. Huh? Answer. How much? Come again? Huh? 10, 10. In that case, you take processing time is into count. Then your answer is CABD. Got it, all of you? Right. Now, can I solve or you need to solve? Right. Where is my pen? Right. Now here, job is job, processing time and due date. Processing time and due date. Now here least slack you need to find. Least slack is equal to, it is processing time minus due date. Is it okay? It is due date minus processing time. Due date minus processing time. Due date minus processing time. Clear everybody? Right. Now here job is what? A, B, C, D. Processing time 8, 6, 9, 11. Next 15, 16, 15, 16, 14, 21. Right. Next is due date 15 minus 8. Next 16 minus 6, 14 minus 9, 21 minus 11. Right. 15 minus 6, 7, and it is 10, and it is going to be a 14 minus, it is 5, it is going to be a 10 again. Right. Now here see, based on the least slack value, you have to select the job sequence. Which one is minimum slack value? Slack value 5. So A is a, so no, C, I'm sorry. Based on least slack, the job sequence is, what is that here? C, A. So here you are getting that for B job slack value and D job slack value are same. Both are 10. Look at here. Done. Now here in that case you select earliest processing time. So that is going to be a B, I guess, right? B and then D. C, A, B, D is your answer, right? This is your answer. Okay, right. Now let's go for another question. Right. Now this question is related to in jobs and two machines. Right. Draw the table. Don't look like all the time. It is not possible to you to explain all the time. Write something immediately whenever you engage the question. But without table, it is not possible to solve the question, isn't it? Finished up? Yeah, please. Yeah. Working here. All right. Fine. Now here it is a end job, two missions. Jobs are there and one mission M1 and M2 is there. Right. Now I told you in the beginning, whenever you engage with the end jobs one mission, EDD rule and SPT rule has to be considered. There you will get average flow time, average steadiness, and also what is that? Lateness, average lateness also will get. But whenever you go for end jobs two missions, the optimum job sequence will be given by Johnson's algorithm. Clear everybody? But here what we have considered optimum job sequence, EDD rule and SPT rule we have used for n job one mission. But whereas n jobs two missions, you are supposed to take Johnson's algorithm. Very, very important. So 90% question is chance from the Johnson's algorithm. Clear? Hope you understand. Right. Now let us take that. What is Johnson's algorithm? Johnson's algorithm provides optimal job sequence. Optimal job sequence. Janssens algorithm provides optimal job sequence. Right now, here, guys, for the first step, what you need to do that you take that how many jobs are there, that many columns you take. How many jobs you have, that many columns you take. How many? 1, 2, 3, 4, 5, 6 jobs are there. Right now, 6 columns you take. 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5, 6. Right now, first step is that you take how many columns are there, that many how many jobs are there, that many columns you take that. Okay, so better you write that. I'm repeating that now, so you forgot later how it is come. Right now, whenever two missions are there, now you take two missions, both side one, mission 1 and mission 2, mission 1 and mission 2. Clear? Right. After that, among all these, they are having some processing times. Listen carefully. Among all these, everyone having mission 1 having some processing time for each job, mission 2 having some processing time for each job. Right. Now here, select the lowest processing time machine or job. Right. Lowest processing time of the job among all these short. Which one? 3. And which mission it is? M1 side. And it is a job U. Right now here, so whichever the shortest processing time that you consider, and whether it is a mission 1 side, then you write it as a U here. Okay, among all these, this fellow is a shortest one, and it is mission side 1, mission 1 on U job. We will get operations on mission 1, mission 2. In mission 1 it takes 3 minutes time, in mission 2 it takes 8 minutes time. Right. Next, similarly, all these jobs having different processing times for different M1 mission and M2 mission. Now, here we need to find optimal job sequence. In which sequence if you go, so that you are able to finish your jobs earliest time. That is what all about job sequence. That is why I ask you to come early. All these things we have discussed earlier. Now you are seeing like this. What is processing time, early time, everything. You look at here. Why always looking outside? Right. Next lowest processing time. Find out that next lowest processing time. 4. 4. So many is there. So here 1 4, here 1 4, here 1 4. Which one you are supposed to select? That is a tricky. Right. Now here if you select that Q. Q having 4 comma 7. Next S is equal to 12 comma 4, and then T equal to 8 comma 4. Right. So now from here you need to select which one is the next processor. Right. Now here see, whenever you are having them some equality, or else same processing time for different jobs, in that which one you are supposed to select. So consider both processing times, both M1 mission 1 processing time, mission 2 processing time, and then select which one is having the lowest values first. Which one having the lowest values? Among this, which one having lowest value? Q. Q4. Q job 4. Which side it is? M1 side. Now here Q. Right. Now it is gone. Now it is gone. Next. In that, which one is less? T. T is the less. And T shortest processing time 4. And which side it is? M. M2. Right. Now here your T. Your T. Right. Now this gone. Next shortest processing time. Yes. Yes. Which side 4? M. M2. Right. Again here it is. Yes. Next. So now here what you just saw, have a small strike off so that you finish this, this, and this. Now what are the rest? P and then R jobs. So now which one having the lowest processing time? 5. Which side it is? 5 only, na? Yeah. So M2. P is M2 side. Then next is R. This is your job sequence. Optimal job sequence by the Johnson's algorithm. Then you will get the optimal job sequence whenever you engage with the n jobs from 2 missions. Clear, everybody? So can I repeat the rule or not required? Huh? Not required. Good. Very good. Right. Now let us form the table again. Let's form the table. UQRPST. Right. Tell me. You ask me, please. That's why I asked you whether I repeat or not. You clear? Can I go for next? Right. All of you taken this? So now make sure that this one statements you will forget because it seems to be very simple. Whenever you try to solve, then your pen will not move. That is why write each and every step. Johnson's algorithm. Right. Now let us go and solve this. And here it is a job. Now it is a mission 1 and then it is a mission 2. Right. So now here job for mission 1. First is a in time in and then processing time and then out and then out. Now similarly here it is a in time of machine 2, processing time, next is out. Right. So now job finished, right? So now tell me the job sequence, guys. Come again. U Q R P S T, right? R P S T. U Q R P S and T. Now let us go for. Now we'll make sure that let me know the processing times, guys. What is the processing time for M1U? See that and let me know because I can't go back continuously. Come on, huh? 3. Oh, yes. 3. Next Q is 7, right? Huh? 4. Huh? Next 4. Next 7, 6, 12, and 8. From your book, you try to solve. Don't copy here. You have a table, na? So until unless you practice, you can't get these kind of things. Okay. So for 3 job, where is your question? Here only, na? Then for U job in M1, what is the processing time? U job M1 processing time 3, like that. You do that. Secondly, you do that mission 2 also. Right. Now for mission 2, it is 8, 7, 6, 5, 4, 4, right? 4 and then 4 again, I guess, right? Right. Right. Now in time. Job U, so listen carefully. Job U in time 0. Very good, my boy. Right. Next, out time 3. Very good. Next. Right. Now here in time of Q job, huh? Okay. And its processing time 4. 3 plus 4, 7 out time. Now this job is again 7 in time and it's going to be 14 out time. Right. Next, 14 in time for the D job and its processing time 6, so that 14 plus 6 is 20, right? And after 20 minutes, S job enter into N and it takes operation for 12 minutes and 32 minutes it will go out. Now here 32 minutes plus 8, so that you are getting is 40. Clear, everybody? Good, very good. Right. Finish, everybody. Right. Now here next topic is that, next step is that, see, mission 1 out time will be mission 2 in time, that is 3 minutes. Okay, mission 1 out time will be the mission 2 in time. Mission 1 out time will be the mission 2 in time. Right. Now here 3 plus 8 processing time. Third minute it will enter. First job U job will get machining on first mission for 3 minutes and it will out. And the third minute finish, then immediately it will enter into the second machine and it will take some time to processing. That processing time is 8, so that it will take total time in the machine 2 is 11 minutes. Third minute it is enter and then 8 minutes it is taking operation and then 11 minute it will come, right? Next. But here you can understand one thing. Until first job U will get processed 3 minutes, that machine 2 is in ideal. Okay, you need to understand that mission 2 is ideal for 3 minutes because U job has to get finished, because according to the Johnson's algorithm the jobs has to finish in this manner, then only you are going to get maximum utilization of the machines. All right, right. Next, whenever you engage, this is out, and what is the in time here? Here in time, why can't 7? Mission 2 is already working for 11 minutes, but your Q job is ready at 7 minutes. But after 7 minutes, it isn't busy with the first job. That is why here, whichever the value is coming maximum in this 2, right? So mission 2 out time for the first job and mission 1 first job out. Which one is maximum? That you have to consider. Clear? Right. Now here it is a 11. So 11 plus 7, 18. Now, so at 18th minute, the job Q is finished. After Q finished only, or will get engaged, right? So though it is ready to get machining after 14th minute, but machine will be busy till 18 minutes, right? Now here it is 18 plus 6 processing time 24. Now here which one is again it is ready for getting machining or operation 28th minute, but machine will be busy till 24. So after 24 minutes you will get. Now here it is a 29. Again, which one is higher? 32. That means here job is finished by this job. P job is finished by 29th minute. But Mission 1 is busy with until 32 minutes. That is why your mission 2 should be ideal. Here, here is a waiting time. Here is a mission ideal time. Clear, everybody? Right. Now here this fellow is 32 and this is 4 na 36. Next, which one is higher? 4. 4. P plus 4, 44. Right? What they ask you to calculate, guys? Minimum make span. That is, what is the maximum value at the out of second mission? I told you that. What is that? Last job which leaves the machine, that is a minimum make span. Last job which leaves from the workstation. T job will be leaving from the workstation, from the machine 2. It is going to be out. Will be the make span. This is what the maximum make span. That means what is the last job spending more time? What is the last job spending time in the machine shop? That is come under your make span. Say that. I hope you understand this is a make span. Alright, guys. Hope you understand this. Finished now? Now, similar kind of problem I'll give. So, try to solve this. All of you okay? Understood? Right. Now, we'll see that. Right. Try to solve this. We'll see how well you are understood this question. And then I will give you one more question. Right, which one you will solve first? This one or this one? Huh? This one? 6 jobs you'll finish? Good. Great challenge. Right. So you keep doing. I'll be back in 5 minutes. That is why I give two problems. Once you finish this, go to here next, like this. You will get it. Help. Thank you.